Alright, so this is the last video from the 1.1 notes. So this is on a little bit touching on some problem-solving strategies and solving applications. And so we're going to look at, again, solving problems. And what you do, you read the problem, make a list, and it can be mental or physical, you can write it down. What information did they tell me? What information am I being asked to find, right? What are you given and what are you asked to solve for? Make a sketch if that's helpful. And apply any formulas that you may need, right? And then solve using your algebraic rule, solve using your order of operations. And then when it's all said and done, you should always give, in application problems, your numbers have meaning, so you should always give your final answer with units. Alright, simplified as a statement, this is the answer with the correct units, right? If it's centimeters, make sure you put it centimeters. If it's a percent, make sure you put a percent. If it's time in years, make sure you put it in time in years, and so on. Alright, so always make sure your statement is with appropriate units. Alright, so a couple simple examples. Alright, so the first example is just a simple geometry type. So we have the volume V of a cylinder, right? A soda can, right? A soda can's a cylinder. It can be given by the equation volume is pi r squared times h, where r is the radius of the circle part, right, the base, and h is the height of the cylinder, right? So again, our can, that would be the radius, and this would be the height, right, of our can that we can measure. Alright, so solve the following. If we measured our can and it had a radius of 1.3 inches, the height of the can was 4.4 inches, find the volume of the can in cubic inches. There's my units. Alright, so then it's just, I read it, I understood the information that I'm given, and so now we're just going to solve using the formula, and they actually gave us the formula. So volume is pi r squared times h, and you just plug the appropriate numbers in the right spot. And so volume is pi, my radius squared, my radius was 1.3 squared, and then multiplied by my h, which is 4.4. And you could type all that out. Actually, I'm going to simplify this first. I'm going to leave my pi out front, because remember, pi is an irrational number. I'll multiply by it at the end. Right now, I'm just going to do the multiplication of 1.3 squared. Don't forget to square the 1.3 times 4.4, which comes out 7.436, and then I'll multiply that times pi. Alright, so the volume is 23.4. Don't forget your units, so the volume is 23.4. You can either write the words cubic inches, or it's probably just easier to use inches cubed. And there's my answer. Right, the second part of this question is, if this is the can and this is how much its volume holds, can hold 12 fluid ounces if I know for every cubic inch, that would be the inches cubed, holds 0.55 fluid ounces. And so this is a conversion. I've got to convert my cubic inches to ounces to see how many ounces this can holds. Alright, so what we do is, again, you kind of use your units here. So I had 23.4 inches cubed. Alright, for every 1 inch cubed, right, 1 inch cubed, it's 0.55 ounces. And so we multiply like this, right? I want to cancel the inches cubed, and I want to be left with ounces. And so it's going to be 23.4 times the 0.55, which will leave me with my ounces. So if we multiply that out, it comes out to 12.87 ounces. So our can holds 12.87 ounces. So can it hold 12? Yeah, it can hold a little bit more than 12, right? So the answer is yes. It holds more than 12 ounces. Or just yes, it'll hold 12 ounces. Alright, next example. Alright, next example is a table example. So application with a table, finding our percent. Right, a lot of times percents are hard for students. Alright, so we want to find percent in this is a particular problem we're focusing on finding the percent. Alright, so we're given the consumer price index between the years 1970 and 2015. And so these would be the consumer price index for all of those years. So it's steadily rising. Alright, so what the consumer price index indicates, it's a typical example for goods. Alright? So, again, what it would cost versus, so sort of talking about inflation, the increase in prices over the year. Right? So, just the first one's just asking you to describe what's happening to the consumer price index over, what is this table telling you? Well, first of all, it's going by 5 years, right? 1970, 1975. And so every 5 years, you'll notice that the consumer prices is steadily, every single time, it increased, it never decreased. Right? So the consumer price index increased over, if you can read this, every 5-year period. Alright, so it's steadily increasing. Prices have continuously increased from 1970 to 2015. Right? And again, you can put that in your own words, but that's basically what the table is showing, right? Consumer price index has gone up every again, they only give me every 5 years, so I can say it over every 5 years, and it does look like it's a steady increase over that time period. Alright, so that was just describe it in your own words. Alright, the next one is asking me what's the approximate percent change in prices from 1975 to 2000. And so it's a percent of the change. So the first thing up top is I have to find, so it's a fraction, right? Percent's a fraction. And fraction is part divided by where we're starting here. So the percent change, we start at 9, so this is where we start. This is where we finish. And so what we want to do is, well, I have to figure out, well, what's the change in consumer price index divided by the starting consumer price index. And then to get a percent, well, we multiply by that fraction by 100 to get percent. And so we find the change. So up top would be the change. Well, in 2015, the consumer price index was 195. If you go look at the table, right, let's look at my table. In 1975, the consumer price index was 54. And so the first thing is I have to find the change, right, the difference. And so to find the difference, well, how much did it grow by? Well, I subtract. I take my 195, which is my 2015, subtract away where we started, right, and that'll give me the difference, how much the consumer price changed over those years. And then you always divide by where we're starting. Right, our starting value was 54, right? We started, when we're looking at this particular problem, we were starting in 1975. Alright, so it's the change over my years. Alright, so I subtract to find the change. And it's an increase, so it should come out positive. So you always take the bigger number minus the smaller number. And then I divide by my starting point, which was 1975, which was 54. Alright, so up top, we take our 195 minus our 54 and spit it out. So the consumer price index increased by 141 over those years. We started at 54. Alright, so I take my 141, I divide by my 54. And then I forgot to write my times 100. That comes out the fraction 2.6. 111 continuously, and then we multiply that by my 100% to make it a percent. So 2.6, and I'm just going to round to the whole number. So it comes out 261% is the increase, the approximate, because I did round. Alright, so the approximate increase is the approximate percent change from 1975 to 2005, which I think I wrote 2015 here. 2005 was what it was supposed to be. I'm going to make sure I put the right number right. I did. Alright, so I wrote down 2015, but I did write down the right number. Alright, so this is all right. This should have been 2015, but the consumer price index, I did write down the right number here. This was 2005. Alright, so the numbers are all right. Just make sure this was supposed to be 2005, not 2015. which I believe I might have said 2015, 2005, right? The consumer price index changed from 1975 to 2005 is 261%. And the next problem I go to 2015. Right, so same thing. I want to know what the change was from 2010 to 2000. So this is where we start. Alright, this is where we finish. So I need to know my 2010 Consumer Price Index, where we start, and my 2015 Consumer Price Index. Alright, so 2010 was 218, 2015 was 237. Alright, so 218, 237. So it's not going to be as much of a, it's going to be a much smaller change. And it should make sense, it's over a lot fewer years, right? This is only over 5 years, which is this one was over 70 years. Right, so there would be a bigger change over 70 years than there was over 5 years. So it should always, again, make sure your numbers make sense when it's all said and done. Alright, so first of all, I find my change. So up top is how much did it change. So I take my 237, subtract away my 218, and divide by the starting point, 218. Alright, and so I find my change, divided by my starting point, and multiply by my 100 to get my percent. Alright, so I'm going to do this first. Alright, order of operations, right? Do the subtraction first. So take your 237 minus your 218, so the change was just 19. It only increased by 19. And then I'm just going to multiply, so I'm going to divide this out and then multiply by 100. So 19 divided by our 218 comes out to the decimal point 0.0871556, and multiply that by 100 to get my percent, which it comes out to 8.7%. So it's a much smaller increase, right? It should make sense. 5 years, it shouldn't increase by as much as it did over 70 years. And so this is the percent change. This is the approximate percent change from 2010 to 2015, which was a lot smaller than the percent change from 1975 to 2005. Alright, so percent change. And percent changes tend to be hard. It's actually one of those things that's not the easiest for me to either have to sort of stop and think about what they're asking me for a change. I've got to find a change. And it's the change from where I'm starting. So we always divide by where we start, because we started at this number and we changed by this amount. And so the percent has to do with, well, how much did we change from our starting value? Alright, so this is the change. This is the starting value. And then multiply by 100 to make the decimal a percent. Alright, the last example. Alright, the size of the Milky Way. Alright, so the speed of light, which again is a really big number, is approximately 186,000 miles per second. So keep in mind this is in miles per second. The Milky Way galaxy has approximate diameter. Oops, and that was supposed to be rewritten. That was the... In yours it should be right. It should be 10 raised to the 7th, so that got messed up when I converted it, made it bigger. So it'd be 6 times 10 to the 17th. If you look at your notes, I do believe it has that. But that 17 should be up in the exponent. Miles. Estimate to the nearest 1,000. So I've got to remember to round to the 1,000 place. The number of years it takes for the light to travel across the Milky Way. Alright, so this one's going to require me to do a little conversions, because I want years, but the time they gave me was seconds. So I'm going to have to convert from seconds to years. And so it's up to you. I'll probably wait to do the conversion last, but I will have to convert. Alright, so you are going to have to convert from seconds to years, alright, which might be the hardest part of this problem. Alright, the first thing, I'm going to find how long it takes. Alright, so I'm going to find, since it's in seconds first, the number of seconds it takes the light to cross the Milky Way. which is just a multiplication, or sorry, a division, not a multiplication, a division. I have to divide my number of miles, which is this number, right? My miles across the Milky Way, by how long? Miles per second. It's kind of like if you were going on a trip and you were traveling 500 miles and you're going at a speed of 60 miles per second. Well, you would take your 500 miles divided by your speed, 60 miles per second, and that's how long it would take you. Well, it's the same thing here. The numbers are just bigger. So I'm going to take my miles, which is my 6 times 10 to the 17th, divided by how long it takes, which is the best way to kind of do it is if you put your units on it. I'm going to divide by my 186,000, remember this is miles per second. So the miles will cancel out and leave me with seconds. Alright, so you type that out on the calculator. So remember how you do this on the calculator. It's 6e to the 17 on your calculator, divided by 186,000. Right, and it should give you a scientific notation. And it does, and I'm just going to round 3 decimal places. 3.226 e to the 12 is what my calculator gives me. Which again means that it's 3.226 times 10 to the... So it's a really big number. There would be... Again, I'd move 3 spots over, and then I'd still need 9 zeros after that. Right? And so it's just a really big number. And so remember, this is my seconds. So this is how many seconds. So again, if I wrote that all the way out, right, that's how many seconds it takes light to travel across the Milky Way. Alright, but I don't want it in seconds. I want it in years. So I have to convert to years. And so I have to find the conversion. Actually, the easiest way for you guys, and since it's an online class, you have access to Google. Alright, the easiest way to do this is I have to figure out, well, how many seconds are there in a year? Right, that's what I need. And so if you Google that, you just say, Google, how many seconds are there in a year? And you use that conversion. Alright, so I'm going to take my 3.226 times 10 to the 12, and I'm going to multiply it by, for 1 year, how many seconds there are in a year. And if you Google that, that number's 315,360,000 seconds. And this is also seconds. Alright, so there's that many seconds in every year. And so what you do is, again, seconds will cancel out and leave me with years. So I take this really big number, that's how many seconds it takes me to cross the Milky Way, divided by how many seconds there are in a year, and that'll tell me how many years it takes for the light to travel across the Milky Way. And so again, make sure you're careful. You've got to type that in as a scientific notation, 3.226 e to the 12, divided by that number, 315,360,000. And it'll come out 0.22996, and that's years, and I'm not quite done yet. Alright, so if you go back and you remember, it wanted me to estimate, because there's a lot of rounding that I did. There's a lot of estimates. So it's a ballpark figure, and so since it's a ballpark figure, it's going to have me round to the thousands, and so that would be this place. And so if I round to the 1,000, it's 102,000 years. Alright, so it takes light about, because I did round, it's an estimate, so I use the word about, 102,000 years to cross the Milky Way. Alright, and so there's an application. And like I said, the hardest part about that application was conversions. But with conversions, again, since this is an online class, you could always use the conversions through Google. Alright, and the Google would convert it for you. But you'd have to recognize that the answer needed to be in years. So I had to convert from seconds to years. You'd have to know that. And then if you want to use Google to convert seconds to years, you can use Google, and then make sure you round appropriately. Again, it's online, so if a problem asks you online to round to the thousands place, and you would have given the program this number, they would have marked it wrong because you didn't follow directions. Right? You have to round to where they're telling you to round, because again, it's not right. Right? You would lose points for that. It would be marked wrong. You got to make sure you round to where they're asking you. So make sure you read problems very carefully. So this one was a read very carefully. It's kind of when I highlighted things. All right. What again? Units. That's why we tell you to put units in all your answers, because units are important. So units help you solve it. So I recognized the first units they gave me were miles per second. Then they told me how many miles it was across. So everything was in miles. So miles matched up, so that was fine. But then when I got down to the answer, they wanted me to put it in years. The time I was given was seconds, so that tells me I knew I had to convert to years. Right? I wanted to make sure my units match, and they don't, right? I have seconds here. I needed years in my final answer. And so that told me I would have to convert from seconds to years. And then the other thing is rounding. Make sure you round it correctly. If it tells me to round to the thousands, make sure you round to the thousands. If it tells me to round to the hundreds, or the whole number, make sure you round to the hundreds or the whole number. Or if it's a decimal, again, make sure you round the way it tells you to round. Alright, so we will stop there. That finishes up 1.1. We'll move on to 1.2 in the next video.